everybody. I'm going to talk a little bit about synthesis and retrosynthesis in this video, and kind of talk about how to set up a little synthetic toolbox for yourself so you can think about organizing those reactions and putting retrosynthesis to better use. So the first thing you really want to identify when you approach a synthesis problem, the first thing that I tend to look for is if there's any change in the carbon skeleton. So there's different ways that you can do that. The first way to do it is really just as easy as counting out the carbon, see if you added or lost any from the starting material to the product. See if you're making any kind of carbon bonds. Okay, that's really going to tell you that you need to make sure that you've got some sort of carbon-carbon bond forming reaction in place. And the nice thing is we really only know two ways currently, so far, we know two ways of installing new carbon-carbon bonds. So basically you've got an alkyne alkylation. Okay, so we've got some sort of alkyne plus a primary alkyl halide, for instance. We can do an SN2 reaction on that. Okay, so we can make a new CC bond in that way. Or we can also use a cyanide, okay, which is going to be a very similar type of idea as the alkyne. An SN2 reaction. Do that again. So that we get to something like that, making this new CC bond. So those are pretty much the only two ways right now. But we will definitely be learning more of those this semester. But for right now, we want to just kind of think about them being fairly focused. And if we see new carbon-carbon bonds in a synthesis problem, we only have a couple ways to do it. So make sure that you're putting those in the forefront of your mind. So then the second thing you want to do is look at kind of the starting and the ending functional groups. Is there a change in the identity of those functional groups? Is there a change in the location of those functional groups? So are you going to need to think about how to kind of like move things around and make sure that you're using, major and kind of selective reactions? So think about, if I want to have something on the least substituted side, am I doing that appropriately? And trying to figure out how to go from one place to another or one functional group to another one. And then finally, just determine what functional groups you have in the product. And that's going to help you start off your retrosynthesis. And as you think about, okay, I've got this functional group, what functional groups could I have synthesized it from? Okay, so what kind of starting materials would that look like? So this process is really important to be confident in your synthetic toolbox, which is what we'll talk about a little bit in this video as well, to make sure that you know your reactions well enough to kind of pull things out and say, okay, I've got an alkene. What's the best way to make an alkene? Well, I could do an E2 reaction with, an alkyl halide. I could do an E1 reaction with an alcohol, and just think about what are some of the ways that we can make that functional group. So when we're doing retrosynthesis, we want to remember kind of how we set things up and what the arrows look like for that. So remember, when we're using our retrosynthesis arrow, we're really looking at some kind of product. And if we draw this retrosynthesis arrow, that means comes from. Okay, so we're looking at that product comes from this starting material. Okay, but if that retrosynthesis arrow is confusing you, you can always do retrosynthesis without the special arrow, but still set your problem up so that you're thinking from the product to the starting material. So the way to do that, so if So if it confuses you, what I would just do is set up a problem like this for yourself. So you've got some kind of product, and then you know that you need some kind of reagents and some kind of starting material to get there. Okay, that's really what we're looking at here for retrosynthesis. Okay, we're starting with this, and then we're getting we have to figure out what kind of starting material we get. But if you don't like this, if that doesn't make sense to you, then do it this way. Start with, say, I need to make this product. What starting material would I use? And what reagents would I accompany that with, okay, to get to this particular product? And that's going to essentially allow you to do a retrosynthesis without really doing it the way that it's usually shown, okay? Because a lot of times this doesn't make sense to people, and that's okay. But you can do the same process, just kind of laying it out for yourself like a box problem, okay? And that's essentially going to make it into a smaller synthesis problem instead of like a really big unapproachable one. So let's talk about the synthetic toolbox a little bit here. So for this, I'm going to give a couple of examples for these, but this is by no means kind of an exhaustive list. I think there's a lot more that you can do with this. And this week, we're also going to be working on this kind of process where I'm going to ask you to delve a little bit deeper and break down this functional group column even more, to the point where we're looking at, how would you make primary alkyl halides? How about secondary alkyl halides? And just getting a little bit more granular there so that we can kind of think about how are some of the ways that we make these functional groups that we see all the time. So this is going to be a little bit more general than what I'm going to ask you to do, because I don't want to steal all your thunder here. And keep in mind that the examples, I'm not going to be giving every single example for every single reaction, okay? So there's going to be some reactions that I'm not going to have as examples, but definitely should be there as examples. Okay, so let's start with an alkane. So when we think about synthesizing alkanes, generally we should be thinking about hydrogenation reactions, okay? That's the first thing that comes to my head, using either alkenes or alkynes. Okay, so if I have this alkene and I do a hydrogenation with hydrogen and some kind of metal catalyst, I'm going to make an alkane. Same thing if I start with the alkyne and do my hydrogenation, get to my alkane. Okay, so that's what we're looking at in terms of this is the functional group product. So this is the kind of starting material that I should have. Okay, so whenever we have an alkene as our final product, we should be considering the fact that we probably have a pi bond in there at some point that we can do more kind of reasonable function with, and then we destroy that function to get to our alkene. So for an alkyl halide, we can make those from alkanes. We learned that recently with our radical reactions. We can also make them from alcohols, and we can make them from alkenes. Okay, so if we look at examples of that, we can have some sort of alkane starting material with bromine and light to do our radical halogenation. So that's going to get us to an alkyl halide. If I have an alcohol, there's a variety of different ways that we can do this. We can use HBr, we can use PBr3, vinyl chloride. We've got quite a few options here. So this is definitely an example where there's more options than what I'm writing down, but we can definitely go from alcohol to alkyl halide. And then alkene to alkyl halide, we've got a couple of reactions for that now too. So we've got the HBr. We can also use the HBr with peroxide, which is our radical version. So again, another example where there's other options here that I'm not including, but you should definitely include. So we can go from any of those functional groups to an alkyl halide with various levels of selectivity depending on what we choose. So if we go to alcohol, we have plenty of alkene reactions that lead to alcohols. We also have alkyl halide reactions that lead to alcohols. So again, we know 3 ways of doing this. I'm going to just choose one. Okay, so I'm looking at most substituted side addition of an alcohol on my alkene. Or if we have an alkyl halide, we can just do a simple SN2 or even SN1 reaction, depending on how you set it up, to get to our alcohol. Okay. So if I've got some sort of nucleophile attached to a carbon group, where nucleophile is like some kind of OR group, a thiol, a sulfide, a cyanide, any of those types of things, they can essentially come from an alkyl halide or a tosylate. But basically, when we're looking at this, we're pretty much looking at some kind of SN2 reaction, right? I kind of lump in tosylates and alkyl halides together in my mind. So if I have something like this, if I add in sodium cyanide, that's going to get me that SN2 product. If I have, a tosylate, I can add in something like sodium methoxide and get to that OR product. So the 1,2 disubstituted, there's a ton of examples here. So keep that in mind as you're kind of making your own toolbox. There's a lot of examples. All of them come from, many of them come from an alkene, right? There's a ton of disubstituted alkene reactions that we've talked about. But epoxide, it can also do a lot of disubstituted things where we can end up with an OH on one side and then some kind of nucleophile on the other side. So whether that's an alcohol or an ether, any kind of like SN2 substrate, all those things, we can do a lot of them with epoxides as well. So the alkene is stuff like, if I've got my alkene and I decide to do osmium tetroxide and the sodium sulfite. Oops, so 3. That's going to give me my syn addition of alcohols. Okay, if I have an alkene and I add in Br2, that's going to give me anti-addition of my bromines. If I have an epoxide, okay, so if I start off with an epoxide here and I add in something like sodium cyanide, right, I can get, well, we'll finish that up with an aqueous quench. An OH on one side, and then our nucleophile on the other side. So all of those are going to give you those like 1,2 disubstituted products. So alkene, we got quite a few ways to make alkenes. We've got some sort of elimination reaction, which is the alkyl halide and the alcohol. Those are both going to be, an E1, E2 type process. Or we can do a hydrogenation from an alkyne. So alkyl halides, we're really looking at, some sort of, I would say E2 is probably the most common using an alkyl halide, where if we have some sort of alkyl halide to start with, we add in a strong base, then we can get various substitutions of alkene out, depending on what base you use. If we have an alcohol, right, that's going to push us sometimes E2, but more often than not E1. And that's with acid to get to alkene products. If I have an alkyne, then I'm looking at more of a hydrogenation type process, right? So if I do the dissolving metal reduction, I can get a transalkene. We should not forget about the Lindlar's catalyst, which gives us a cisalkene. But again, make sure you fill this out a little bit more completely than what I'm doing. Our alkynes, we can get those from alkyl halides through 2 E2 reactions. So if I have 2 bromides. Scooch that down a touch. And then I throw in a really strong base. Okay, that's going to get me to an alkyne. I can also start with an alkyne and first do an acid-base reaction on that terminal carbon, and then do an SN2 reaction with a primary alkyl halide. And that's going to give me an internal alkyne. And then finally, we can have a ketone or an aldehyde, which we have seen synthesized so far from alkynes. We will be able to add to many of these throughout the semester. So, make sure that you're kind of having a way to add in as you go. But if we're starting with alkynes, we can either do the one where we add to the most substituted side, okay, which is our acid catalyzed hydration with the addition of mercury. That's going to give us a ketone. If we do the hydrobration oxidation method, that's going to give us our aldehyde and give us the least substituted hydration. So those are all going to be kind of good ways to think about this. So we want to kind of have our thoughts organized in terms of, this is what I'm trying to get to. This is what I could be starting with. And then we've got different options from there. So having a more descriptive version of this is often helpful. So you can get a little bit more granular and just kind of think those things through. So let's look at an example here. So this is just a problem that I took from the book. There's a lot of really nice kind of practice problems for synthesis in this chapter, in chapter 11. So definitely take advantage of that as much as you can. So as I'm going to start this, I'm going to think about step 1 here, and we're going to look at the carbon skeleton. So it's often helpful just to start off by adding some numbers here. Okay, so we're kind of starting off where we can see a little bit about, where our initial starting material came from, especially due to the nice, helpful methyl groups that we've got installed. And then we've got 7, 8, 9. So we need to add 3 carbons. And we're using that, we're making a carbon-carbon bond between 4 and 7. Okay, so that 4 to 7 bond being carbon-carbon and not having any evidence of any nitrogen around anywhere, we should be thinking an alkyne alkylation right away. Okay, so knowing that there has to be an alkyne here at some point, then at that stage, we should be looking at this alkene. And if we look at the alkene section, we can see, okay, I can make that from an alkyl halide, an alkyne, or an alcohol. But we've already said we probably need to have an alkyne here at some point. So let's focus on that stage, right? Once we identify the fact that we need to adjust the carbon skeleton, add more carbons, make a carbon-carbon bond, that makes these syntheses of alkenes just a little less useful when I can kind of cut myself, I can cut some of my steps down a little bit by going straight from an alkyne to an alkene. So let's include that in our retrosynthesis. So that alkene probably came from an alkyne. Okay, and then let's add our numbers, make sure we didn't mess any of that up. Like I did, definitely did. There we go. Okay, that's why we number. It's very helpful. It's very easy to lose stuff. Okay, so that alkene probably came from that alkyne. And then if we're looking here, we need to make, at some point, we need to address the fact that we need to make that 4 to 7 bond. But now that I have an alkyne there, that actually looks a lot more reasonable because I know that I'm going to need to do an alkyne alkylation at some point. So I probably should be having something where I have that alkyne reacting with an alkyl halide. So something like this. And then I've got myself an alkyl halide, right? So if I go to the alkyl halide section, so I can have an alkyl halide from an alkane, from an alcohol, or from an alkene. I am given an alkene as my starting material. So any way that I can try to get this one to work, some sort of alkene starting material here, that's going to be really, really helpful. And again, kind of just make my life a little bit easier. So if I can think of some way to go from this alkyl halide to that alkene, that's going to be just finished, right? So this is definitely one where we can do the HBr with peroxide and have our bromine installed on the least substituted side of that alkene. So this is going to be my retrosynthesis. So my forward synthesis, and you can definitely put more notes around here just to kind of keep yourself straight as you go. But it's really up to you. Like the retrosynthesis kind of your plan, right? Okay, so for our forward synthesis, we're going to start at the end of the retro and go this way. So first off, we need to do that radical hydrohalogenation to put our bromine on the least substituted side. Wait. Once I don't add extra carbons that we don't need. Okay, so we can get to this intermediate. And then we need to do our alkyne alkylation. Okay, so we can use our deprotonated alkyne. And if we need to make that, we definitely know how, right? We can just do some sort of acid-base reaction with sodium amide or sodium hydride. And that's going to get us to this intermediate that we identified in our retrosynthesis. And then we just need to do the hydrogenation of an alkyne to a transalkene. And that's going to be our dissolving metal reduction with some sort of metal and ammonia. To get to our final transalkene product. Okay, so definitely this is going to be helpful to kind of go through this process as many times as possible. But just think about as you're going through a retrosynthesis, just try to make your life as easy as possible, right? If we have identified that we need to do some sort of alkylation, don't try making that alkene from an E2 reaction, right? We can do an alkyne reduction, and that's going to be much easier. So this is going to take practice. We're going to practice this the rest of the semester, but we're going to kind of dedicate this week to it as well. So as always, let me know if you have any questions, and I will see you all later.